to best. On this channel, we don't just jump to optimal solutions. We start with the simplest idea, understand its limitations, and then gradually improve it. The same way you are expected to think during interviews and real problem solving. In today's video, we are going to talk about binary search. Not just how to write the code, but how to think about it correctly. Now, before we begin, let me clearly mention few assumptions. I am assuming that you already know: 1. What binary search is at basic level. 2. That it works on a sorted array. 3. And that it reduces time complexity from order of n to order of log n. So, this video is not about introducing binary search for the first time. This video is about understanding when binary search actually applies, why it fails so often in interviews, and how small condition mistakes can completely break it. And just a quick note, if binary search or time complexity is still new to you, drop a comment below. I will create a dedicated beginner video for that. Now let's start the way we should always start, with brute force. Suppose I want to find a number in an array. The most straightforward idea is to check each element one by one. Now this approach always works. It doesn't require any assumption. But problem is performance. For large arrays, this approach takes linear time, that is order of n complexity. Now, here's an important point. Binary search doesn't replace brute force. It optimizes brute force, but only when a specific condition is satisfied. Most people say binary search works on a sorted array. And it's true, but it's incomplete. The real requirement is you must be able to eliminate half of the search space with confidence. Now, sorting is just one way to guarantee that confidence. Any problem where the answer space behaves in a monotonic way can potentially be solved using binary search. For example, if we write it, let me clear this. So if our answer space is something like this, or sorry for the auto completion, or this way. So here clearly the answer space is in a monotonous way, right? So any search operation or any find operation on this answer space, we can use binary search for that. Okay. Now these transitions tell us that binary search might apply even if the problem doesn't explicitly say search. This is where many people get stuck. They think binary search is about finding an element, but in reality, binary search is about making a decision at mid and then confidently discarding half of the remaining space. In interviews, this thinking matters much more than memorizing the code. Let's now look at a basic binary search template. I don't want you to memorize this. I want you to understand what each variable represents. So I will just write a basic binary search code which most of you might write during interview. So just to save some time, I have already created a class binary search. Now I will just add a method here, public method binary search, which will return the index of target value, right? So binary search, and it will take two parameters in the method signature. One is the numbers integer array, which will contains this number space where we will find the target, and a target value which we need to find. Now I will quickly write or initialize some variables, right? Okay, now some people just write this way: int right equals to nums dot length. Now this is straight away incorrect because we know that indexing in array starts with 0 index and goes up to the total size of the array minus 1 position, right? So nums dot length, it will give, after final iteration, it will give us array index out of bound exception, right? So we must use length minus 1 here. Okay, now we will have a while loop which will iterate, right? And then we need to calculate the mid, and mid, correct. So just for to give you a context, if our array is of 10 elements, so mid will be either 5 or fifth or sixth element, since it's an even numbers in the size of the array is even. But if it's 11, the mid will be sixth element always. So that's why we are taking it as int, so that it will not calculate the fraction. It will always have a definite integer value. Okay, now so here we will check whether our mid is equals to target value or not. So let me write it this way: mid equals to target. So if our mid value matches the target, we will straight away return the mid, because this is the index where the target is available, correct? If it doesn't match, then we have to check whether the target value presents left side of the mid position or right side of the mid position, so that we can discard the other half, right? So we just have to check nums mid is less than target. If it's less than target, means it's in the left side of the array, right? So we will simply update the left position. Sorry, my mistake. So if mid is less than of the target, that means target presents on the right half of the namespace. So we are changing left's value, and similarly, if it's greater than, that means target present on the left side, so we will update the right position. Okay, and now after all the iteration, if we couldn't find any match, we will simply return -1. That means there's the target is not present in the given number space, right? So this is how most people write a program for binary search. Here, left represents the start of our search space and right represents the end of our search space. So in every iteration, we calculate a mid and we make a decision. Then we reduce the search space by half. Now here's a rule you should always remember. Every iteration must strictly shrink the search space. If it doesn't, the algorithm is broken. Now let's talk about why binary search fails so often. So just to give you a better understanding, I have created a test class with some test data already. Okay. So now initially I will just pass one test data. So I will comment out everything. Okay. Fine. Okay. And now I will run this test binary search. Okay. So you can see test one, the index, the target value present. So this is the target one, target value present at one, and it pass, right? Now let us try. Now let me give you some problems where this current code will break. So first problem is this line, while left less than right. So this is not correct condition. So for example, if we add our test data, if we can modify our test data, and let me add this value in the test data. Okay, let me remove it from here, and our target should, let me update it to 5 for the second test data. Right now here our namespace is of length 1, so array will have only one element and we want to find that element only, right? So our expectation is it should return index 0 and test should be pass, right? Now let us execute. Now it couldn't find the target value in the given namespace and status is fail. Why it failed? Because here we have mentioned the condition left less than right. Now let's analyze. Okay, so here num array. Now this nums contains only one value, right? So nums is equals to 5 here, correct? And so we are initializing left equals to 0. Now right is equals to nums dot length, which is 1, and minus 1. That means 0. So here right is also 0, right? So when it is checking while left less than right, this condition never satisfies and the no iteration is happening on the namespace and we are straight away returning -1. Okay, so first fix we should do here is we should add less than equals to 0. Okay, now let us execute the search test with this update. Okay, now status is still saying fail. It's something not because of our code error, it's because of something else. Let me just show you. Here the expected we didn't update it. Expected is 0 and we are expecting 4, that's why. So let me run it again. Now status is pass, right? Okay, now second problem. Second problem is something which I can't show you after run, but I can tell you in the theory with this mid calculation. Now here it in general or in common eyes this looks perfect. So we are basically adding left and right and dividing it by 2 to find the middle. That's the general concept of finding mid of any range, correct? But what if left has a huge number and right also has a huge number? For example, if our array size is, let's say, 4 billion, and after first iteration we have reduced it to 1 billion, right? Sorry, 2 billions, and left is starting from the mid, that means 2 billion, and right is ending at the 2 billion 1 or 4 billion, let's say. Now in that case, when we calculate this mid value with those high numbers, it will be out of range. The calculated value will be out of range of the integer uh, size, right? So our mid will be not the correct mid, it will contain the garbage value, and which will break the entire logic of the binary search, right? Now to fix this issue, one thing we can do very simply, that is, here we can have this calculation. Okay, now this simple change, what it is doing. So let's take smaller example and understand, right? So let's take this array. Let's say this is our namespace. Whether it will calculate mid correctly or not, right? So initially left is 0 and right is 4, correct? Because we have 5 elements, so length 5 minus 1, 4, correct? So let me write here left is 4, right? And let me remove nums from here. Now mid, so left is 0, 0 plus right 4, 4 minus 0, so it will eventually become 4, and divided by 2, that is 2. So it will give me the index 2 value, that is 5. Mid value will be 5, right? Now after second iteration, let's say our target, let us consider target from our target example only. Let's say target is 1, right? Now we will compare whether mid equals to target. So 5 is equals to 1, no, that means, and then we will check target is less than mid, no, that's also not correct. So it will go into else part, and it will update right as mid index, that is 2. So now L is still 0, right has updated to 2, and now again if we calculate mid, so left is still 0, 0 plus right is 2 minus 0. So again 2, 2 by 2 is equals to 1. So again we will get the correct mid, right? Let us check whether it will satisfied if the target is greater than mid value or not, right? So let's say our target is now 9. Okay, so again for first iteration mid value will be index 2 only. Here this condition will be satisfied whether mid value less the target or not, right? Then we will update left equals to mid. So now left is updated to 2, right is still 4. Okay, now comes to second iteration. Here left equals to 2, 2 in right we have 4, 4 minus 2, right? So it will give me 4 minus 2, 2, 2 plus 2, 4, 4 divided by 2 is 2. So it will again calculate the 4. So you can see here we are getting some incorrect value. That is because of some other problem in the logic that I will come later. But for now, you just understand that changing mid calculation logic solves our problem with the large integer data. Okay, so that's the second problem. Now let me clear the comments. The third problem, updating the beginning and ending of search space correctly. Okay, now let me show you one problem you already saw where when we were trying to calculate the mid, it wasn't calculating correctly, right? Second problem, let me just try doing something like this. Okay, now let me uncomment all the test cases and I will run it. Okay, so it only ran for 2 test cases. Why? Okay, so actually it didn't run only for 2 test cases. The application is still running. So basically it went into an infinite loop. Let me just quickly update something for your understanding, right? So let me add something, some print sysouts here, right? So that you will be able to understand, right? So let me give some value, let's say left plus left, sorry, and mid. Okay, and let me just place it after calculation of mid value, right? And let me quickly update. So let us not send all, anyway it will not make any difference, but let me quickly update. Okay, and let me comment the previous working test status. Okay, and we have to update this value to 9. Target is 9, right? Okay, now let me run it. See, here you can see it's keep on calculating. Why? Because it's goes into an infinite loop. Why infinite loop? Let me explain. So let us take this nums array, so inputs, right? So let me add some comment here. This is our nums and target is 9, right? So this is the last element in that array which we are trying to find using binary search. Okay, now let's go one by one. Okay, so let me write it here. Let me break it and I will just add something. So let's go one by one iteration. So on first iteration, it will come here. Now left value is 0, right's value is 4, right? So here this condition will be satisfied. Mid will be calculated to 2. So mid is equals to 2, right? Because 4 minus 0 is 4 plus 0, 4, 4 by 2, 2. So mid index is 2 and mid, let's say we call it mid E. Mid E is 5. That is middle element is 5, right? Now it will not satisfy this condition, but it will satisfy this condition because 5 is always less than the target value 9, right? So now left is updated with mid. So coming here, now left, sorry, now left is 2 and right is 4. Now come here, it will calculate again. So 4 minus 2 is 2, again plus 2, 4 divided by 2. So mid will again become 2 and mid element is again 5. It will again comes here. This will not satisfy. This condition will again get satisfied. We will again update left is equals to mid, that is 2. It will come here and so on. So it will keep on going the same. It will keep on going through the same loop again and again. So if you can see in the log as well. So here left is 2, right is 4 and mid is 2 in each and every iteration, right? So that's the problem. Now what should we do to solve this problem, right? Just a small modification and our this problem will also be resolved. So let me quickly remove the commented lines and all. Okay. And here what we will have to do, we will simply have to do for left, we will update it to mid plus 1. Now why mid plus 1? Mid we have already checked and it is satisfied. So we can simply change the range from mid plus 1, right? And simply similarly for right, we can exclude the mid and we can update the right to mid minus 1. Now if I run the test, okay, just give me a second. Yeah, I'm extremely sorry. I just made a simple mistake. So here we should remove this parenthesis because first we should divide it by 2 and then add it with the left. Now, so left means the current left. Okay. Now I have updated the code correctly. Okay. Let us check our test cases. Yeah, this is fine. So now if we execute it, okay. So see, now the calculation you can see. So on the first iteration, left was 0, right was 4 and mid calculated 2. On the second iteration, left is updated by mid plus 1, that is 2 plus 1 3. Then right is 4, mid calculated as 3, and on the third iteration, left was updated to 4, right was still 4, mid is calculated as 4 and this condition gets satisfied, it returned mid. So the test returned the index 4 and status was pass, right? So these are the corrections we can make to make our binary search code foolproof. Okay, now let me quickly uncomment all the test cases just to show you in one go. Okay, so and let me update the targets and expectations. 5, that is fine. Then 9 4 6 minus 1 6 2. Okay, so I guess we are done. Let me quickly explain you. So our first test data will be this array 1 3 5 7 9 and the target value is 1. So expectation is our binary search should return 0 as the target index. In second test value, we have only one element in the array 5 and target value is also 5. So our expectation is our binary search algorithm should not break and it should return 0 as the target index. On the next test case, we have this array 1 3 5 7 9 and our target value is the last most element of that array. And expectation is it should also work and return 4 as the target index. And the fourth test case, we have the same namespace numbers array but the target value is something which doesn't belongs to the number array, right? So our expectation is it should return 1 as the index, right? And we have also taken an array with the even number of elements. Even number of elements means the size of the array, length of the array is even. It's not about the elements are even, so I can change the element to anything and then we can check. Okay, now let me quickly run this all the test cases. See, okay, let me remove the additional comment we added. Okay, this is, now let me run. So all our test cases was passed and it matches the expected result, right? So let me show you the expectations. So for first test case, expectation was 0. Second test case, expectation was 0 again. For third test case, expectation was 4, -1 for fourth test case, and 2 for fifth test case, right? So now you understand that the dangerous part of writing any code is that code often looks correct, but it fails on edge cases. So whenever you write the binary search, you should mentally test it against a few edge cases. For example, let me write it down all the examples here. For examples, okay, target is at the beginning of the array, right? Second, target is at the end of that array. Okay, target is not present. Sorry, right? Even length arrays. Okay, and very large value, right? So it can have when you get any test question, it will definitely clearly define the value possible. So you can see that it always defines very large value possible, right? So we should take very large values as our edge condition. So if your solution, whatever you write, handles all of these, it's likely or it's very likely to be the correct solution. So here's the takeaway. Binary search is not about speed. It's about confidence in elimination. Means we should be able to eliminate half of the search space after each iteration. Always start with brute force. Understand why it works. Then ask yourself, can I eliminate half the search space safely? If yes, binary search applies. If not, it doesn't. If you found this way of thinking helpful, this channel is exactly for you. We will continue breaking down DSA problems from brute to best, one pattern at a time. Thanks for watching. I will see you in the next video.